We're going to talk in this lesson about distance and midpoint. Distance and midpoint. So what we're talking about here is given a line, or given a segment of a line, can we find out what its distance is, its length, so the distance between 2 points, and find out the midpoint, right? So what we'll do is we'll just get a little line sorted out here between this point here and this point here, and let's firstly tackle the question of distance. How far is it from this point here to this point here? Okay, so what we could do is we could measure it, but we don't tend to do too much of that. We use information, don't we, from the page. We don't sort of get our rulers out and say that's the length so much anymore. We look at the evidence based on the numerical information we're given. So how else could we find out what that distance is? So what we tend to do is we tend to look at look at what we've got in terms of the how many units across we've gone, how many units this way, and if we find out those lengths there, then we can use what we know about right-angled triangles, and that is the squares of the shorter sides when added together each equals the square of the longer side, this being the hypotenuse. So the green length could be calculated by finding out this horizontal length, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6 on the vertical length. And we could work out the distance, couldn't we, if you remember this little relationship here, c squared equals a squared plus b squared, where c is the hypotenuse and a and b are the shorter sides. Now the hypotenuse in this case is what we're trying to find. So we would say that c squared is equal to the a and b are the two shorter sides, 6 squared plus 8 squared, right, 36 plus 64, which is 100. So c is equal to the square root of 100, isn't it? Which is equal to 10. So we can work out the distance of the distance between these 2 points, the length of that green line, by using Pythagoras. That's how we tend to work out the lengths of non-horizontal, non-vertical, or oblique, as they're called, lines. Non-horizontal, non-vertical. If they're horizontal or vertical, you just count squares. So we're looking in terms of units rather than, say, getting the ruler out and measuring it in terms of centimeters or millimeters. Okay, so that's 8 units across, 6 units up, and we use Pythagoras to find out what the distance is. Okay, that would probably make sense, wouldn't it? And I think that would be our method. Now, how about the midpoint? The midpoint of this line interval here. So the midpoint, I'm sure you understand, would be the point in the middle. Okay, so how do we find this point in the middle? It's around here somewhere, but let's have a think here. Maybe you're having to think about it too, hopefully. But if we're going 8 across here and 6 up here, then do you think if we go 1, 2, 3, 4 across, 1, 2, 3, 4 across, and 1, 2, 3 up, and find that point, do you think that would be the midpoint? Let's have a look at it anyway. 4 and 3, so that's that point there. Does that look like the midpoint? So have we split this interval in half? If that's 3, and that's 4. Well, yes, we have. We've gone halfway across the horizontal, halfway up the vertical. So we are, and that is all any line does. It goes, say, 4 units, 3 units, 4 units, 3 units. So that point there is the midpoint, and so 4 units across and 3 units up from this point here, because that's halfway along the horizontal distance from this point to this point, and it's halfway up the vertical distance from this point to this point. So that's the sort of mathematics we're going to use now to find the distance and midpoint of an interval that connects 2 points. So we're going to go back in here and we'll have a look at a number plane now. So we'll label our number plane x, y, and we'll look at a couple of points and then start to do some mathematics on it. So let's take the point, say 1, 2. 1, 2, 3, 4, 1, 2, 3. So we might do the same thing. 1, 2, 3, 4, 5, 6, 8, 1, 2, 3, 4, 5, 6. So we're going to join these 2 points here, where this point here is the point 2, 1. And this point here is the point if we've gone along now, if we've gone along 6 and up 8. Is that what we did? 1, 2, 3, 4, 5, 6, 7, 8. No, we went along 8, so we're now at x equals 10. And we went up 6, so we're at the point 10, 7. So there are our 2 points. And what we want to do is to find the distance between those 2 points and the midpoint of them. So we'll call this, we'll give these guys names. We'll call this point A and this point here B. So distance AB, alright, will equal, well, we've already worked it out. We know that the distance is, because that's 8 and that's 6, we know that the distance is 10. But what I want to do is I want to use the coordinates 2, 1 and 10, 7 rather than having to draw this triangle out each time. So the distance AB, let's use Pythagoras to find it. But what we're doing is we're finding these lengths, but we're going to use the difference between the x coordinates 10 and 2. So 10 minus 2 gives us this 8. So we're going to say the distance AB is 10 minus 2 squared plus, now the rise here, the 6 value comes from 7 minus 1. 7 minus 1 squared, so that's the square root of 8 squared plus 6 squared, which is the square root of 100, which is 10. Okay, so that's the distance AB. The midpoint AB will be halfway between the 2 and the 10 on the x-coordinate, so it's going to be 2 plus 10 divided by 2. That's how we find out halfway between 2 points. If we want to go, okay, let's find out halfway between these 2 points on the number line. And let's say this is 3 and this is 11. Then to find halfway along, what's the point that's halfway between them? We could sort of count, or you could add them together to get 14 and divide by 2, and that gives you the point. So 3 and 11, the midpoint is 7. So we add the two endpoints together, divide by 2. So if we go back now to our, so we take 2 and 10 and divide by 2 for our x midpoint, and we take 1 and we add 7 and divide by 2 to get our y midpoint. So that's 12 over 2 and 8 over 2, which is 6, 4. And if you go back, that is what we discovered there. Well, actually, we didn't have points to work with. So the midpoint of 2, 1 and 10, 7 is 6, 4. And if you look at it, 1, 2, 3, 4, 1, 2, 3, that point there will have coordinates 6, 4. 1, 2, 3, 4 up, 1, 2, 3, 4, 5, 6 across. Okay, so that's how we're going to find our distance and midpoints. If we want to generalize now, which we tend to find useful, we want to generalize. So what we'll do now is we'll just pull out, there's my x coordinate, there's my y coordinate. So now what we're going to do is take 2 points. We're not going to give them exact values. I'm going to say that this point is the point x1, y1, and this point here is the point x2, y2, x2, y2. Now if we join those 2 points, then what we can say is that the distance will be equal to the square root of. Now what do? We find the difference between the 2 x coordinates and square it, and the difference between the 2 y coordinates and square that difference, sum them and take the square root. That will give us the distance between those 2 points using Pythagoras. Now the midpoint, which is somewhere in there, we're not really sure where it is, somewhere in here, our midpoint our midpoint is equal to, it's the sum of the two x coordinates over 2 and the sum of the two y coordinates over 2. So there are our two formulas that we work with. When you've got the 2 points, you can apply those formulas to find the distance. So we'll just do an example of that. Example, find the distance. Okay, so in this example, we want to find the distance between the points point A, minus 1, 4, and B, 3, 1, and also the midpoint of that interval. Okay, we don't need to draw this up, but it might just assist us with our understanding of the question. So go to minus 1, 4, which is up here somewhere. We're not going to worry too much about exact, and 3, 1 is over here somewhere. So we've got minus 1, 4, and over here we've got 3, 1. So what we're after in this question is we're after the length, the distance between those 2 points. So we're after this distance here, and we're after the midpoint. So the distance will equal the square root. Now what we can do is we can just label these points x1, y1, and x2, y2. It doesn't matter which way around we put those, x1, y1, x2, y2, just for the point of the formula. So this distance is the square root of x2 minus x1 all squared. So x2, which is 3, so we just put that into the formula, minus 1 all squared, plus y2, 1 minus 4 all squared. Okay, so that's the square root of 3 minus minus 1 is 4 squared, 1 minus 4 is minus 3 squared, and that's the square root of 16, minus 3 squared is 9, so that's the square root of 25, or 5. So the distance is 5, and that's just applying that formula. Just being careful with your arithmetic here, double negatives, that sort of thing. Remember, whenever you square a negative, you're going to end up with a positive. So we're always going to end up with 2 positive numbers here, and we take the square root. And in this case, we have 5. If this is not a square number, if it's a square root of 20 or a square root of 15, we just leave it like that. So that's the distance. The midpoint is equal to, this is a point, so it's got xy coordinates. So it's x1 minus 1 plus x2, which is 3. Remember, we're using this formula here. x1 plus x2 over 2 is our x coordinate, so we just put that over 2. And our y coordinate at the midpoint is y1 plus y2 over 2. So y1, 4 plus y2, 1 over 2. Simple as that. So our midpoint is minus 1 plus 3, which is 2 over 2, and 4 plus 1, which is 5 over 2. And then we just simplify. 2 over 2 is 1. This is 2.5, but I'm happy for it to be left as 5 over 2. So our midpoint is at 1, 2.5, which is up here somewhere. Distance and midpoint. Okay, we're ready now to tackle, I think it's G, exercise 1G. I'll see you on Thursday in class.